Okay, this is just a quick video with some vocabulary terms for graphing. Easier if we're speaking the same language here. So one of the words we're going to need to know is the quadrants. If we're looking at a graph, we're often using a Cartesian plane, and a Cartesian plane has a line that runs horizontally, although it's straighter than that, and vertically, also straighter than that, and those are called the axes. There is a y-axis, and the y-axis I'll highlight here in green. Again, that's just wiggly because my hand is wiggly. And we have an x-axis, which is going to be here in pink. And they are at 90-degree angles to each other. They are orthogonal to each other. They are perpendicular to each other. They are at right angles to each other. That's all ways of saying that the angle inside here is 90 degrees. So in those two axes, we've got, well, two number lines, right? We start at 0. This point here, where the two cross each other, is called the origin of the graph. That's the base, where 0, 0 is our coordinate there. So if we're labeling a point anywhere on the graph, we give the x-coordinate first, then the y-coordinate. So here, that would be 0, 0, because you go on the x-axis, 0 steps left or right, and on the y-axis, 0 steps up or down. So the origin is right there. On the x-axis, we've got a number line that goes from 0 over this way in the positive direction, and over this way in the negative direction, working just like a number line. And on the y-axis is the same thing, going this way in the positive direction, and this way in the negative direction. So there's no reason why it had to be that way, just that's the way it is. If you want to know for sure why that is, you can ask René Descartes, who came up with this Cartesian plane. When we're graphing things, it's good to sometimes know what kind of general area we're in. Are we over here? Are we over here? Where are we? So if we're looking at a point and we've got a point maybe that's right there, we could label this point with the x-coordinate, 6, and the y-coordinate, 4. We know that gets us exactly to here, so we would start at the origin, count over 6 places, and then go up 4 places. Both those numbers, 6 and 4, are positive, so we know they're going to the right and up. So we know here that all of our x values are positive, and all of our y values are positive. Anything, whether it's here or there, any point that we could make is going to be positive in the x direction and positive in the y direction. Starting from the origin, we're only going right or up, or both. We call this quadrant number 1, and we often use a Roman numeral for it. Don't know why. The next coordinate, we're starting from sort of this line here, and we're going to work our way around in that direction. We're going around counterclockwise. We would be doing the same thing if we were measuring angles as well. We would start at 0 degrees and then come up to, I don't know, 30 degrees, 45 degrees, 90 degrees, over to 180. We would go in that same counterclockwise direction. So the second quadrant, we labeled 2. And if we pick some point in there to plot, maybe this one, we could say that the x value here is -4, and the y is +2. So this point is -4, 2. And for everything in this quadrant, our x-coordinates will be negative, and our y-coordinates will be positive. So if you see a negative number, then a positive number, you're going to be sure you're in the second quadrant. In our third quadrant, which we label number 3, we pick a point to plot somewhere, anywhere in this region over here, it doesn't matter. Pick this one. This is -6, so 6 steps to the left of the origin, and 2 steps down, so that's -2. I'm going to rewrite that a little bit nicer. -6, -2. So in here, all of our x values and all of our y values will both be negative. And in our fourth quadrant, which I'm sure you can guess is numbered 4, it's the same idea. If we look at some point, maybe we pick a point that's right here. This point here, in the x direction, we've gone 2 steps to the right, so that's 2. And in the y direction, we've gone 4 steps down, so that's -4. Anywhere in this quadrant, we'll be going to the right, which means our x values are positive, and we'll be going down, so our y values are negative. If we look at the overall graph, anything on this side will have positive x values, and anything on this side will have negative x values. Anything up here will have positive y values, and anything down here will have negative y values. Those two are independent of each other. The x and the y bits are independent of each other. And anytime we're labeling a coordinate, our x value always comes first, and our y value always comes second. So it doesn't matter where we are or what we're trying to show, the x value comes first and the y comes second, and we do them inside of brackets with a comma in between. Another thing that we need to know about is slope. So a slope is the measure of a line on a graph. It has to be a line. If we have a line here that's going up, I'm always going to read from left to right. So if it's going from left to right up, we would call this relatively steep. We can assign a value to it, and we will later, but right now this is relatively steep. And since it's going up to the right, we would call it a positive slope. Here, reading from right to left, or sorry, left to right again, this is not as steep. So these terms are not precise. We'll assign values to these later. But this is a less steep slope that is also positive. If we have a line that doesn't go up or down, so it just goes from right to left but doesn't go up or down, this slope is, it's got an e in it as well, equal to 0. No slope. I forgot to plot one, but if we did have a line that went straight, hang on a second, I'll put a line in here, a line that went straight up and down, so no rise, no run, we would say that this one has, well, we can't. We're going to call this slope undefined. So for a vertical line, we say that the slope is undefined. We'll be measuring the slope later as what we call the rise over the run. Rise is the change in the y values, and run is the change in the x values. So if we pick any 2 points and we subtract the y values, get the change, subtract the x values, get the change. Here, the x value is not changing, right? I'm not moving any further left or right, which means I would be dividing by 0, and I can't do that. So that's why we say undefined. And for this line, I guess I'll use a different color here. For this line, the slope is 0 because there's no change in the y coordinate. If I look at here or here, anywhere along this line, my y values aren't changing, but my x ones are. So that's why the slope is 0, because it's 0 divided by anything, which is 0. Over here, we have a not so steep slope that's going down to the right. So we'll call that a negative slope. And over here, we have a steeper one going down to the right. So we would call this slope steeper. We can calculate it by taking a point here and a point there and finding out the differences, finding the slope mathematically, But just for a quick overview, the steeper, the more like this or this a line is, we call it steep. The more like this or this, we would call it shallow. If it's horizontal, we say no slope. If it's vertical, we say the slope is undefined. Another term we need to know is intercept. And this is usually going to be the y-axis intercept. So this is where a line crosses the y-axis. So here my y-intercept is 0. It crosses at 0. Here my y-intercept is at -2. Where y is -2, that's where it's crossing that line. So when x is 0, x is 0, x is 1, x is 2, -1, -2. When x is 0, so this is when x equals 0, the graph will show -2. And here when x is 0, so not 1 or not 2, but at 0, where does the line cross? Here my y-intercept is at +2. You can also have an x-intercept. Where it crosses the x-axis. And that happens, when the y value is 0. So when the y value is 0, we would be there, or we would be there, or in this case, our x-intercept is also 0. We would be there. We'll commonly ask for y-intercept, sometimes ask for x-intercept. And it's always asking the opposing thing. So when x-intercept is when y is 0. Y-intercept is when x is 0. Which if you have an equation, you can plug 0 in and evaluate. Two other terms I want to talk about before I go. Extrapolation and interpolation. Extrapolation is extending a pattern past what you know. So say you know this. You know that much of a pattern. And you want to know what comes next. Well, if the pattern follows a straight line, which in this course it will, it doesn't always, of course, but we could take a ruler and extend that line. We could extend it out that way, or we could extend it out that way to get these different regions. It doesn't matter. If it does follow a straight line, you can usually just lay down a ruler and see where that graph is heading. You can do the same thing by not setting a range or domain on your graphing calculator. So extrapolation means what's extra. I know between here and here really well, but what's going to be beyond that? Well, draw a line. Very, very similar is interpolation. Interpolation is I know that point and I know that point. I want to know what's in the middle. So in most cases, and in this course for sure, we can connect those 2 points with a ruler, and we can say, all right, so what if the x value was 2? Okay, a is 4. What if the x value was 4? Sorry, the x value is 4, the y value is 5. But what if the x value was 3? Before, we weren't sure about it, but our best guess would come by just extending the pattern and seeing, okay, where would we be at? So we would be at about 4.5. So we can guess that this point here is about 4.5. So the x-coordinate is 3, 1, 2, 3 steps over, and the y-coordinate is 4.5, 1, 2, 3, 4.5 steps up. Okay, those are some terms we'll be using in this unit and talking about graphing. Sorry the video went longer than I thought, but I think you can deal with it.